The universe is full of complex questions, but sometimes you need to get back to basics. One such question that has intrigued people for many centuries is how the sun, despite the absence of oxygen in space, manages to emit heat and light. In this article, we'll delve into the science behind this phenomenon, examining the role of oxygen in fire, the composition of the sun, and the nuclear fusion process that makes it shine. Contrary to popular belief, there is a small amount of molecular oxygen in space. It has been detected in places such as the Orion Nebula, the Rho Ophiuchi cloud, and even the galaxy Markarian 231. However, it is scarce and is not responsible for the burning effect of the sun. Fire, as we know it on Earth, requires free atmospheric oxygen, which is found in abundance only on our planet. The sun is composed primarily of hydrogen and helium. Approximately 91% of its atoms are hydrogen, and helium, 8.9%. With this composition, oxygen cannot be present in significant quantities. Therefore, fire, which requires oxygen to burn, is impossible on the sun. Instead of fire, the sun generates heat and light through a process called nuclear fusion. The sun's enormous mass creates intense pressure and temperature at its core. At about 15 million degrees Celsius, these conditions are ideal for nuclear fusion. NASA explains that at the sun's core, hydrogen atoms fuse together to form helium. The fusion process releases an astonishing amount of energy. It is this energy that produces the heat and light of the sun, illuminating our solar system. Although the sun does not radiate direct thermal energy into space, we still feel its heat on Earth. In the nearly empty vacuum of space, there are fewer particles to interact with, making it more difficult to heat matter through radiation. Instead, the heat we feel on Earth is the result of solar radiation emitted by the sun. Solar radiation covers various wavelengths of the electromagnetic spectrum, including visible light. These radiations interact with particles present on Earth, resulting in the sensation of heat. It is this interaction that allows us to bask in the sun, despite the lack of oxygen in space. The lack of oxygen in space does not hinder the sun's ability to radiate heat and light. While fire requires atmospheric oxygen to burn, the sun uses nuclear fusion to produce its radiance. When hydrogen atoms fuse into helium, the sun releases enormous amounts of energy. This energy, in the form of solar radiation, interacts with particles on Earth, allowing us to feel the sun's heat despite the vacuum of space.